Hello guys, today I'm gonna show you a project of mine in regards to retaining walls. I decided to make this video as I think there's much information on YouTube about the theory but not so much about the practical execution of this kind of jobs. So I'm gonna teach you this in a very practical way. If you wanna see some videos about theory, you can check so many channels on YouTube to learn more about this kind of jobs. It all started with a call from a client regarding a retaining wall that was literally moving slowly towards failure. Okay, so as you can see in these two pictures, the wall had already moved 6 centimeters in a couple of years, and we could already see some cracks, particularly in the middle of the wall. So this is the final solution I come up to, but you will see during the video that the 3 meters and 50 centimeters represented in this picture will not be executed exactly like this. Okay, so on site we will only have 3 meters and 10 centimeters, so it's going to be shorter than this solution, and I'm gonna read you all the calculations considering that fact. Now I'm going to show you the design steps from a geotechnical safety perspective. Okay, so first of all we have got to think about the dimensions and the active earth pressure that's gonna develop in our wall. Okay, so you can see in my calculations here that we're gonna have a retaining wall with 3 centimeters thick, 310 centimeters high, and we're gonna have a footing of 60 centimeters thick and 250 centimeters large. I used Coulomb theory to calculate the active earth pressure after talking to the client and get to know what was the work done before. We could conclude that the internal friction angle was conservatively 30 degrees. So how do we calculate the active earth pressure? We calculate it using this formula around here. So we need to know the weight of the soil and the height of the wall. To determine the first factor, Ka, we use this formula, and these are the angles that you can find in thousands of videos here on YouTube. You can find the explanation, and using these values I'm gonna get Ka equals to 0.30. That means that the active earth pressure is 41 kilonewtons, and converting it into two directions, we're gonna have around x-axis 36 kilonewtons and around y-axis 21 kilonewtons. Here you can see their representation of the forces acting on the wall. After this, we can check the safety factors. So first, we have got to check the sliding. Safety factor, the formula is around here, and you just have got to put the values that we had in here. We just have to put them inside this formula. We divide it, and we get to 150, which is what we wanted. So sliding is okay. The overturning, here you can see the representation of the forces. You can see the moment at O, at point O, the overturning, and the stabilizing moment. And we have got a safety factor of 3.50, which is, again, very much okay. Then we have got to design the reinforcement for our concrete pieces. And for that, we have got to determine the earth pressure at rest, which is going to be the first pressure that's going to develop in our wall, and that's going to make the wall move just a bit so that the soil will plastify, and we're gonna get the active earth pressure that we determined earlier. So how do we determine earth pressure at rest? IO. From this formula, as you can see, there's no friction angle because this is earth pressure at rest. There's no movement at all, and we determine IO from this formula, and it's 69 kilonewtons. From here, we can design the foundation reinforcement. We have got the moment acting in our wall. We have got the weight of the wall. We convert it to the center of gravity of the footing, and here you can see all the formulas that I use to determine the tension on soil. Also, it's going to be determined. So in this case, only part of the footing will be active, not all of it, because there's no traction on soil, so there's just compression, and you can see here how I determined it. The wall reinforcement design is going to be determined in a very simple way again. The 69 kilonewtons force acting a third of 3.40 meters high, and here I used a very simple formula. Okay, this is a very simplistic formula. This is most of the cases very conservative formula. So here I consider a diameter of 16. We need 6 units, and I always put some more. So this is going to give us 16 millimeters with a spacing of 15 centimeters, but in this case I used 10 centimeters on both sides of the wall to prevent and control cracks. And final, I'm going to present you the side drawings. So here you've got the first solution. I told you earlier that this was not the final height. We did it a little bit shorter. Here the units you need for the reinforcement on the footing, and here on the wall. And now I'm gonna present to you some photos of the execution, and I'm gonna start with the foundation. So this was the first concrete that was put in just to prepare the surface. Then we have got the reinforcement of the footing, and in this picture you can see the spacing of the wall reinforcement. This is the continuation of what I showed you in the previous slide, and this is on the end of the first day, and some steel bars that we're gonna be using them to support the formwork and the shoring of the wall. So the formwork of the wall was done in 2 steps, in 2 phases. Okay, so first we concreted the wall until a height of 2 meters, and then we did the final metering. You can see here some pictures of it again. The final result was a very successful one, in my opinion.